Hey guys, we're back for our last video, and this is the last section of the unit circle. So 5-4, we're dealing with the right triangle trigonometry. So on the unit circle, how each coordinate is formed is by a right triangle. And we can use this right triangle, and this goes back to geometry, okay? And we know that a right triangle is hypotenuse is the slanted side, right? And then we have the adjacent, because the angle is here, right? Angles that is right next to, and then opposite angle of t would be here. So this is why the cosine would be x over 1, which would be x, and the sine is y over 1, which would be y. So when we're dealing with sine, cosine, and tangent, okay, we're talking about right triangle relationships. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and we have tangent, which is opposite over adjacent. And the way people remember this is SOHCAHTOA. So, right, S-O-H. So sine is opposite over hypotenuse. SOHCA, right, ka, is C-A-H. So it's just a way to remember it, SOHCAHTOA. Okay, let's do some problems together. It says, given the triangle, find the value of cosine t. So we're given the angle t here, we need to find cosine. Well, we know cosine, right, is adjacent over hypotenuse. So we're going to look at angle t. The adjacent side would be 15 over the hypotenuse, which is 17. So we just write 15 over 17, and these are both, well, this one's prime, but we can't simplify it anymore. So that's it, okay? The next part is relating angles and their functions. So we have, again, the sine, cosine, tangent, which we know is, these are what define them. And then, again, it's reciprocals, remember? We have cosecant, which is the reciprocal of sine, secant, which is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So the reciprocals, you just flip whatever it is. So if it's opposite over hypotenuse, it becomes hypotenuse over opposite, and so on. Okay? Let's move on to the next one. Number 2, given the triangle, find all 6 trig functions. So we need to find sine. Remember, sine is opposite over hypotenuse. So here's our angle. We're going to go opposite, which is 4, over our hypotenuse, which is going to be 5. Let me make sure. Yeah, it's not really slanted. I did a bad job of that. Okay, but 4 over 5. So this is our hypotenuse, opposite, adjacent. Okay? So cosine would be adjacent over hypotenuse. So we have 3 over 5. Tangent is adjacent over it's opposite over adjacent. Oh my goodness. So we have 4 over 3. Okay, and basically we know that cosecant, right, is hypotenuse over opposite, or just this flip. So we would write 5 over 4. This one would be 5 over 3, and this one would be 3 over 4. And then you're done. These are a lot easier when we're dealing with right triangles. Okay? Let's move on to finding trig functions of special angles using side lengths. Okay, so there's different scenarios for the right triangles. We have 30, 60, 90, right, which is pi over 6 on our, we're dealing with these right here. Okay, pi over 6, pi over 3, pi over 2. Okay, so this is 30, 60, 90, and then we have 45, 45, 90, which is pi over 4, and pi over 2. Okay, these have certain, when we're using the special angles, okay, their side lengths are going to be s over here. This would be s, 2s, and then the square root of 3 times s. Okay, over here we have 2 times the square root, the square root of 2 times s. We have s and s. Okay, so we're just going to be using these to help us solve based on whatever triangle that we are given. So let's take a look at this next one. So if we have pi over 3, we're finding the value of all 6 trig functions of pi over 3. We have to decide which triangle are we using. Well, if it's pi over 3, we know it's going to be a 30, 60, 90. So first thing is first is decide which one we're going to use, and then you determine which sides we're using. Okay, so this one, we are 30, 60, 90. Hint, hint, on your own question, you're going to be using this one. Okay, so sine for pi over 3. Okay, and we're dealing with this angle. So remember, sine is opposite over hypotenuse. So we're going to go opposite over hypotenuse. So the square root of 3s over 2s, right? Well, what do they have in common? They both have s in common. So this just becomes the square root of 3 over 2. And we know that if we look at pi over 3 on our unit circle, that's the square root of 3 over 2, and that's for sine. Okay, they're just showing you how these coordinates are, why they are the way they are. This is how the coordinates come about. Okay, let's do its reciprocal, so cosecant. So we would just flip this. So 2s over the square root of 3s. We know that we can simplify it to this, right? But then we need to get rid of the radical on the bottom. So we have 2 square root of 3 over 3. Okay, for cosine pi over 3, we have to look at up here, right? Cosine would be adjacent over hypotenuse, so s over 2s, which simplifies to 1/2. And again, we look over here, pi over 3, and cosine is in fact 1/2. Okay? So we know over here it's the reciprocal, so it's 2s over s. Cancel the s, it's just 2. Or the reciprocal of 1/2, which is 2. Tangent and cotangent, our last two. So tangent, remember, is what? It'd be opposite over adjacent. Okay, so our opposite one, since we're dealing with this one, my opposite is the square root of 3s over my adjacent, which is s. Okay, what do they have in common? S's. So the s's cancel out and I'm left with the square root of 3. Okay, over here, I'm reciprocal, so it's s over the square root of 3s. The s's cancel out, but I'm left with 1 over the square root of 3 times by the square root of 3. I get the square root of 3 over 3. Okay, just 3 more questions and then we'll be done. So let's move on. Remember, you can pause the video at any time if you need to. Okay, so we're talking about using equal cofunction of complements. So now we're given these cofunction identities. Okay, there's cosine, sine, tangent, secant, cosecant, and cotangent. Okay, so we're given these as rules. These identities are like rules to guide us. So on number 4, we have the cosine of pi over 2. Well, if we look at cosine, right, it's going to be sine times pi over 2 minus t. So we would need to go ahead and write that. So what would be our t in this case? What's our t? It'd be pi over 2, yeah? So we're going to use these identities to plug in what we know. So right away, we know that pi over 2 minus pi over 2, okay? So let me just quickly verify something. I am so sorry. This should say pi over 3. This should say pi over 3. That's all that's messed up. I knew it looked funny. Alright, cosine of pi over 3. So we need to find this out. So we have pi, I'm taking this one, right? Pi over 2 minus our t, which is pi over 3. Okay? But when I'm subtracting fractions, remember, something's gotta be matching, the denominator. So I have the sine of, and I would make the denominators equal. The least common multiple would be 6. So if I times this side by 3 and this side by 2, I get 3 pi over 6 minus 2 pi over 6. So I get the sine of 3 pi minus 2 pi is just pi, so it's pi over 6. Okay, so you can type this into your calculator, right? Sine pi over 6, pi divided by 6. Oops, I'm in radians, make sure you're in radians. Sine of pi divided by 6, 0.5. Or you know that that's a half, right? So we can look over here, and if we're at pi over 6, I know that my sine would be 1/2. Okay? So the cosine of pi over 3 is a half. Okay? So let's do the given triangle, the next one. We're almost done. We need to find its unknown side. So we're given 30 degrees. I know that's tiny. Right? And we're given A, C, and 7. Okay, so we need to take what we're given. So I know that I'm given, this is the opposite, adjacent, hypotenuse. If I have the opposite, what can I solve for? I could solve for sine, right? Or I could solve for tangent, whichever one you guys want to do first. So let's do sine. So we have sine of 30 degrees is equal to, and it's opposite over hypotenuse, so 7 over c. Okay, if I times by c to both sides, I get c times sine of 30 equals 7. Divide by sine of 30. C is, and then we would do that in the calculator, 7 divided by, oh, switch to degree again. Make sure you guys are doing that. Okay, it's easy to forget. So 7 divided by sine of 30. I get 14. Okay, so C is 14. Okay, the next one, we need to solve for A, which is, we can solve easily for that one. Okay, now that I have that this is 14, right, I could do cosine of 30 is equal to, ready, adjacent over hypotenuse. So adjacent over the 14. If I times by 14 to both sides now, so I have 14 times cosine of 30, that's going to give us A. 14 times the cosine of 30, get 12.1. Okay? Make it easy on yourselves. Okay? One last one. We want to know what's the height of this tree. And in our lesson, they go into talking about the angle of elevation and angle of depression. Well, just the angle of elevation is an angle that's above a horizontal line, and an angle of depression is an angle below the horizontal line. So here we have a horizontal line down here, and we have a degree. We have an angle above, so this would be an angle of elevation. Okay? That's just for you guys to know. What's the height of the tree? So now we have to set this up. This is our last one. So I have my adjacent, and I'm missing my hypotenuse. So adjacent and hypotenuse, that's dealing with tangent. Tan is opposite over adjacent. Right? So I have the tan of 57 is equal to, what's my opposite? I don't know. And my adjacent is 30. So times by 30, times by 30. So 30 times the tangent of 57 is going to give us our x, the height of the tree. So I have 30 times the tangent of 57. Make sure you're in degree mode. Okay? And I get 46.2. 46.2, and then it was in feet, so feet equals x. Okay? That's it. I know this week was long videos. We are done with the unit circle. We're going to be moving on to some new stuff, okay? I'm proud of you guys. Keep it up.